Okay, welcome to Vectors and Scalars lecture, and I'm going to spend 10 seconds on each slide, so make sure that you have something to write with, and you can stop and go back over this. There's going to be three vector systems here, and we're going to add the vectors. This is vector addition. The first one is going to be 1200 newtons north or up, and 800 newtons down, and then the resultant vector will be the addition of these two vectors. So it'll be 400 up. This is actually vector addition, where I'm treating those vectors mathematically with magnitude and direction as if they were integers. Now I have 600 newtons up, and I have 800 newtons down, and then the vector addition as a result of this will be 1200 newtons down. Okay, so then the next one is actually a three vector system. I have 20 newtons to the left, and then I have what we call the normal force, or the force normal. That's the up direction, and then the weight or the gravity will be in the down direction, and that would be 50 newtons. So you can see that the up and down cancels, and I'm left with 20 newtons, or will be left with 20 newtons to the left. So 20 newtons to the left is the answer to that one. Now, the next one, very simple vector system, 3, 4, 5, with 30, 40, 50, 300, 400, 500. So 3, 4, 5 would be a special case. I want to go on a journey. First, you go 10 kilometers west and then 5 kilometers south. There's the 10 kilometers west, and then I'm going to head south. I go 5 kilometers south. Change this actually to 5 seconds per slide, and then there's my hypotenuse. You can see how I'm doing the addition, the graphical analysis, and that's going to be 11.2 kilometers, and then the arctangent of 5 over 10 would be 26.6 degrees. So notice I have my compass in the upper right hand corner all set up, and that's a summary, the resultant of my problem. Here are 4 vectors that I want to add graphically. I'm going to get a ruler and a protractor and a scale, and the first one is 50 newtons at 30 degrees south of east, and then 25 newtons, 270 degrees, and then my next one is going to be 80 newtons at 180 degrees, and my last one will be 20 newtons at 20 degrees north of east. Remember, you're using scales and a protractor in order to get this. Notice I go from tail at the origin to head, and that was my vector. You may want to rewind that to see, but this is going to be the same exact problem using vector addition by components, the component method, where I'm taking each of those vectors, 50 newtons at 30 degrees south of east, and what I'm doing is I am breaking them down to their corresponding components. So I've done A and B, now I've done C, and then D's coming up, and I'll do D, which would be trig now. What I'll do is I'll add them. The sum is going to be, for the X will be negative 17.9, and for the Y, negative 43.2. That's obviously in the third quadrant. Take the sum, the square root of the sum of the squares, 46.8 newtons. The arctangent of the absolute value of y over x is going to be 67.5 degrees. Don't forget your plus, plus, negative, plus, etc. And identify the signs of the sums, and that will tell you what is going to be the compass directions of the 67.5 southwest and the third quadrant, and the equilibrant will simply be equal and opposite. Equal magnitude but opposite direction. Now we want to do another problem where we're actually going to use a pencil and protractor and ruler, find the scale, and then when we're all done, then we'll go from the origin to the origin tail to the head of the last vector that I put in, and there are the 5 vectors I'm going to do. And here's the first one. Is going to be 7 kilometers south. That's A. Notice my 1 kilometer is 1 centimeter. Now I'm going to go 22 kilometers east, and those are my other. Now let's C and D now, and then E, which would be 70 degrees north of west. Remember, it's relative to the x-axis, and then there's my answer. Okay, so that should be pretty straightforward. Use a ruler, use a protractor, and there's my, that was my summary. And what I can do now is I can graph A, B, C, D, and E all from the origin, and then I know what my resultant is, and I can put in my resultant. This is a kind of a way to summarize everything that you've done. And so the resultant is there, and then the equilibrant would be there. And there is the summary of the problem. Now, here's the exact same problem, but what I'm using here is I'm using vector addition and the component method to do the exact same thing that I did graphically. Exact same thing. So you can see that I've done A and B now. Now C is going to require some trigonometry, so I'm going to have to use sine and cosine to get my magnitude. But I've got to analyze, well, where is it? It's going to be south of west, so it's going to be negative and negative. And you have to be able to analyze where the vector actually is in the Cartesian coordinate system. So what you would do is then you would put in -2 and -3.46. Same is true. Excuse me. Same is true for D. And then there it's going to be negative because it's obviously south and west as well. And that's going to be the value. Okay, so that is A, B, C, D. Now E is coming up. E is going to be 14.1 is the Y, and 5.1 is the X, and that's going to be north of west, so that'll be positive and negative, and then that's going to be the sum. I'm sorry, that's my E, and then the next thing I'm going to put in is the sum of those components, positive 11.9 and negative 1.56, and then I have to analyze those. Now the next thing I'm going to do is I'm going to analyze the sums relative to the resultant, the magnitude, and the direction. And I'm going to find that the magnitude is 12, based on the Pythagorean theorem, and the arctangent for the for the direction would be arctangent 1.56 over 11.9, which is 7.5 degrees. Look at the sum, and you see that that's positive and negative there. And so that would be positive and negative would be, what quadrant would that be? Well, that would be south of east. South of east. Next, the summary of this, if I actually graph the sum, positive 11.9 and negative 1.56, that's what I get. And then the Pythagorean theorem I would apply to the hypotenuse that I'm going to draw in there. We're going to call that hypotenuse actually the resultant. And then the resultant would be 12. Remember, this is kind of a summary. We've already done this. Would be 12 kilometers, and then the angle would be 7.5 south of east. And that would be a summary of the problem that we just did. Here's a problem. A plane is headed north 90 degrees straight up at 480 miles per hour. It's being blown west by a 50 mile an hour wind. What is the plane's resultant velocity? So we can draw the box, and then from the box we can analyze it as a parallelogram. Remember, you have now, this is the third, we have three different things. We have the addition of components, we have the graphical analysis, and then we have the parallelogram. We could use this as a simple way of doing things. There's going to be the components. You can see right away what the components are. It's very simple. Or we could just simply say, we could do the Pythagorean theorem based on what we have there. And also the arctangent. We wouldn't really need to do anything other than that. So pretty straightforward when it comes to doing these problems. They should become essentially second nature to you. And we see that that is going to be in the second quadrant. That should be pretty obvious. And there's a summary of the problem for you to study. Make sure you can do all of these yourself. A skydiver is falling at a rate of 18 meters per second at 270 degrees. If 9 meters per second wind is at 0 degrees, what is the resultant velocity of the skydiver? These problems should be second nature now. Here are some a review of the methodology that we're using. So none of this should be much of a surprise to you. Again, here's the problem delineated, and we will do the problem. The first vector, A, to say is the skydiver. It's going to be, those are the components. That's going to be the wind. We're going to add that, get the sum. We're going to have positive 9 and 0. I'm sorry, positive 9 and negative 18 will be the sum. And then the magnitude and direction should be pretty straightforward relative to that. So the sum, the square root of the sum of the squares, 9 squared plus negative 18 squared is 20. And then the direction would be arctangent 18 over 9 would be 63, and it's going to be positive and negative, and that will be obviously south of east. And then that would be quadrant 4, and that will be the problem that we just did. And we'll do another problem. Now here are two problems, or a problem, two vector system. And this is the way, this is just basically a review of what we've been doing. Here are the two vectors, and what you do with the two vectors, you break it down into their corresponding components, the x and y. So you're taking the resultants and kind of working backwards. And the b vector is going to be positive, positive, and the a vector is going to be negative x and positive y. There's the math. for each of them, and a corresponding hint relative to the signs of each. Put those into a table, and that's what I get for the table. And there's the sum for each, and then you see that the sum 14.8 and positive 80.6 using the Pythagorean theorem, that's going to be 82 meters per second, and then the direction is going to be 79.6 north of east. And I'm just going to let this play out. You should be able to do this without any problem whatsoever. So you can see what I'm looking at here. I have the resultant, I have the opposite, equal and opposite, equilibrant, and then the summary would be here. That's a summary of the problem with the resultant and the equilibrant. Okay, good luck on your test. You shouldn't need it. You should be very well. Ready for your test. And have a good day. And goodbye.